Hey there, welcome to Unit 7. This unit is going to be on compounds, all kinds of stuff about compounds. We're going to start off first about determining what kind of substance we have. What kind of substance do we have based on its properties? We call this qualitative analysis, analyzing the quality of your substance. So, how do we go about testing a substance to see what it's made of? Well, what we can do is we can test its melting and boiling point because every substance has its own unique melting and boiling point. This is the temperature, of course, at which the phase changes, and it is completely dependent on how strongly the molecules are attracted to each other, or the ions, or the atoms, or whatever you happen to have. Vapor pressure. This is pressure exerted by vapor, and as attractive forces get weaker, more vapor is produced, therefore producing more pressure. Electrical conductivity is the ability to pass charge through a substance, like passing water through a garden hose. Some substances easily pass electricity through them, others resist passing electricity through them. There are also some properties that are inferred based on what we see on those previous properties. We can infer what types of elements are involved. Is a substance composed of metals only, a combination of metals and nonmetals, or just nonmetals only? What type of bond can we expect to see between these? Ionic, covalent, or one we haven't looked at yet, metallic. Metallic bonds do not make compounds. That's what holds metals together, metal atoms together, and also forms alloys. So each bond can be determined by the physical properties of the substance that we took a look at in the beginning. So let's take a look at solids, for example, of course, where the atoms or ions or molecules are arranged in a regularly shaped geometric pattern called a crystal lattice. Ionic solids consist of ionically bonded metals and nonmetals, as you learned in the previous unit. Remember the sodium ions and the chloride ions arranged in a regular crystal lattice. Okay. Molecular solids are involved with substances bonded covalently, which means they're made of nonmetals only. And molecules are separate and distinct particles that are attracted to each other in the solid and liquid phase. Water molecules are individual, distinct, discrete entities that attract to other molecules. This right here is showing water in the solid phase. Network solids are similar to molecular solids, except instead of being made of individual distinct particles, all the atoms in the solid are bonded together. There are no distinct molecules within it at all. This here would be an example of diamond, where we have carbon atoms that are all bonded to other carbon atoms. There are no distinct molecules that can separate from each other. The whole thing is just one mass of covalently bonded carbon atoms. And metallic solids involve metallic bonds. See, metal atoms are not terribly attracted to their valence electrons, so these electrons are free to flow between metal atoms. And so what you end up with is positive nuclei and the under the valence electrons. We call this the kernel, the atoms underneath the valence electrons, with the valence electrons flowing freely between the atoms. So they're basically sharing electrons by losing and gaining them. It's kind of a hybrid between ionic and covalent. However, this does not result in the formation of metal to metal compounds. It can create metal to metal mixtures. See, in a compound, you have to have a fixed proportion of elements. But in a mixture, the proportion does not have to be fixed. So, metallic solids, you can see the electrons crawling. I'll say that again. You can see how the electrons are free to move between the atoms. If you were to force electrons in one side, the electrons would all be pushed to the other side. Imagine a hose filled with water hooked up to a faucet. The water molecules inside the hose can go wherever they want. However, if you turn the hose on, it will force the water in the hose out the other side, and this is like conducting electricity. First test, melting point. As you increase the melting point, the attractive force increases. So a substance with a low melting point will have weak attractive forces, and a substance with a high melting point will have strong attractive forces. Ionic solids have fully positive and fully negative ions attracting each other. Full charges are very strongly attracted, leading to high melting points for these ionic solids. For example, salt melts at 1074 Kelvin. Molecular solids are attracted only by partially charged ends. Remember polar, oh, we haven't done polar molecules yet. Well, in the same way you can have polar bonds, you can also have polar molecules. But these lead to partially charged ends, not fully charged ions. And fully charged is going to beat partially charged every time. Water actually has a pretty high melting point for its size, 273 Kelvin, due to something called hydrogen bonding that we're going to look at in the next video. Network solids have no individual parts that can be separated off of the substance. The whole thing is made of atoms that are covalently bonded together. Therefore, their melting points are extremely high because in order to melt a network solid, you have to break the covalent bond. Diamond is an example of a network solid, and it melts at 3,823 Kelvin. That's a very high melting point. Metallic solids, well, they have varying melting points. Mercury melts at 234 Kelvin, which is why it's a liquid at room temperature. And yet tungsten, which is used as the filament in incandescent light bulbs, can take heats that would make it white hot, 3,695 Kelvin melting point. So you have a wide variation. There's another metal, gallium, that would melt if you put it in your hand. Its melting point is just below body temperature, although I wouldn't recommend doing it because you can actually absorb the metal into your body through your skin, and you do not want that to happen. Here's another test, electrical conductivity. You can only have electric charge conducted when charges are free to move. These charges can be in the form of electrons or ions, and as long as the electrons or ions are able to freely move, you can make electricity go from one place to another. Ionic solids are made of ions, which are charged particles. In the solid phase, all these ions are locked into a crystal lattice and unable to move. So ionic solids will not conduct electricity. However, if you heat them up until they melt, or dissolve them in water, the ions will break free of each other and will be able to move from place to place. So if you take an ionic solid and melt it or dissolve it in water, then it can conduct electricity rather well. Molecular solids have no electric charge. Therefore, they will never conduct under any circumstance. Well, one circumstance. I mentioned it briefly last unit, something called acids, but we'll look at that later in the year. And network solids are made of, again, covalently bonded nonmetal or metalloids. And because they don't have any charges, they also will never conduct under any circumstance. Metallic solids will conduct under every circumstance. Some metals are better at conducting than others, but all metals will conduct electricity to some extent. As opposed to ionic liquids and solutions, where the charge is caused by the movement of ions, in metallic substances, it's due to the movement of electrons. So, this is how you can distinguish between these four different types of substances. Next up, we're going to take a look at molecular polarity, molecular shape, and dot diagrams for molecules. But until that day, which can be now if you wanted to, I will bid you once more adieu, and I hope you have a wonderful day. Bye 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 bye.